Hey everyone, my name is Dave Sexton, and this is my 6th video in my series of videos on reactive programming. And in this video, I think I'm going to jump back to reactive programming. I don't want there to be too many videos in a row where I'm not focusing on reactive programming. And in the previous video, I think we took the much needed leap up to the outer shell of our app's design, which is the GUI, so that way we could design from the outside in a little bit. So now we have a GUI to work with instead of the spec. Most of the time we could just look at the GUI, and we'll come up with some input and outputs that make sense in the business layer, aside from the ones that we've already done, and try to come up with a nice contract or set of contracts that will meet the requirements. But that doesn't necessarily mean we're going to dive in and implement them just yet. But we want to try to have a business layer that makes sense, right? So let's first take a look, because I need to refresh my memory where I left off. And you know what, I think I'm going to close the spec for now. We could always open it up and refer to it later when we need specific items from it. But for now, we're going to just focus on the GUI requirements based on what we've defined already. And I think we could just take a look at this and see what I've done already. So we know there's the connection view with the business layer, I think, mostly done regarding the connection view, right? Actually, I don't remember how far we got with that. I thought it was pretty close, though. So that would be in reactive program. So in reactive program, we have connections, right? Oh, so this is probably something worth pointing out. Oh, I forgot. We never really filled in the main method will probably come in once we're going to have some sort of object-oriented program, too, probably, to compose dependencies together, and then we could just put them as a dependency in main here. Connect could be orthogonal, although connect could also just be our main method in a sense. Yeah, you know, I don't want to get too far into this because it doesn't really matter. We could just implement this once we need it. For now, I still want to concentrate more on design rather than implementation, so I'll just ignore this for now. But what I wanted to point out, actually, was that if you're looking for where queries are defined in the application, you really only have to go to one place, which is nice. So we know here, these are all the queries that we've defined so far. There's going to be many more, obviously, by the time the app's done. But what we have here so far is the outputs that we care about, right? We take all the inputs, and then we compose them together in some ways in order to generate outputs. That's our goal. So we have these inputs here. We could see their inputs because they're local variables, right? They're not exposed publicly. And then we have a couple outputs here. We have invalid usernames and invalid service URLs. So this was meant to implement the connection view. You know what? I think we'll ignore the chat window now. Let's just focus more on connection because I don't think this is completed. There's a few features that we're missing here. So let's, now that we have the connection view XAML in pretty good shape, let's use this as our spec, right? So this is like our designing from the outside in. This is like, or designing by contract, right? This is the contract. We need this functionality and the behavior that goes with it, which is more implied than actual at the moment, but at some point we will have to implement that as well in the presentation layer. And that's just going to be a matter of converting events mostly into observables as input into the business layer, and observables coming from the business layer, subscribing to them to generate output for the interface, the GUI. So that will happen probably in a later video. We're not going to get to that in this video. But for now, we're just looking at the outer shell, right? Just the contracts we define. What is this app supposed to do at a high level? And then now we're going to jump to the outer shell of the business layer and make sure that our contracts make sense in the business layer as well. So we're going to focus on our observable inputs and our observable outputs to make sure that we could support the features of the view, the connection view in this case. I guess it also means we can close the main window and the features. So it's really these two things we care about now, this connection view and this reactive program. So, you know, I don't know that we really care about seeing the XAML here. I think it's probably good enough to just look at the designer. So I'm going to collapse that, and then let's put this vertical so we can look at both at the same time. This might be somewhat helpful. So the consumer of this is going to construct an instance of reactive input, which is defined down here, with all of the properties set, and then pass it into the constructor, and then we'll use that to build up our observables. We want to know what are the inputs and what are the outputs that we'll need in order to implement this interface, strictly this interface. So let's ignore what we've done already, just because I just want to sort of verify that what we've done makes sense, given that we now actually have a graphical interface that we're going to have to hook up to this at some point. So we have a username text box, and this view may be shown multiple times. So we could have a stream of observable stream of strings, which represent the different usernames being pushed in. And that is in fact what we already decided would make sense. So that first property looks okay. And likewise, service URLs, also string because they're raw data coming in from the input, well, from the user. We'll have to validate that, right? When you click submit, I think was for the password box, which is hidden. Maybe it does make sense to have this split anyway. Not really. It's kind of hard to see though. Well, I have a lot more space on the right, so let's try to make the best out of the limited space I have with this resolution. For some reason dragging's not working perfectly. There we go. That's good enough, I guess. So now if we expand this out, we will see that there's a third dock panel here which has a password box in it, right? So having an observable of string and observable service URLs is enough for phase 1 of the authentication process, but this is invisible at first. And the submit and cancel button are also invisible at first, and they are related to the password, right? So you see it's submit password, and cancel actually is not about submitting the password. Cancel is just there all the time during the authentication, or excuse me, during the connection phase, which may include authentication if the server requires it. So yeah, now it's coming back to me. So these buttons aren't part of the first step. The first step is this dock panel contains the text box here, then this dock panel, one under it, contains this text box here, and they correlate to these observables, string of usernames and observable string of service URLs. And we will get those values and validate them even before the end user clicks this button, which is behind these other two, which has the word connect in it. So before they even click the connect button, we can provide validation. And we're providing validation orthogonally. It's output. So it's not part of this input observable or the data type inside of it, which you could actually model it that way with like duplex mechanism, like a callback mechanism rather. But we're doing it a different way. We have outputs on our reactive program that we will set, and those outputs that correlate to these two inputs are the invalid usernames and invalid service URLs. So this is good enough, but this is interesting because it also means that we don't have a place for a validation in this UI. We never did that. So I think for the case of failure to authenticate, we are using the status bar in the main window, if I remember correctly. For more localized input validation errors, I think we should support that in the UI itself. That would make more sense. So the UI, ideally, well, if we were going to implement this, we would have some control or something that would be toggled. Its visibility will be toggled based on the current error state that the business layer provides to the UI. So how would we want to consume that error state? Well, perhaps the simplest way would be to subscribe to some observable with the semantics of letting us know that the username is invalid or the service URL is invalid. And we can automatically clear the error here implicitly when the user clicks connect. So I type in a username and I hit tab, and I'm already subscribed to this, say, observable of unit of invalid usernames. If I get a notification before the user has done anything else, as a matter of fact, we could even require it to be a synchronous notification, not asynchronous. We want to make sure that if the user enters an invalid username, that there's no race conditions where I'll be able to click connect before I get the notification that the username was invalid and slip through an invalid username to the server or something like that. And the way we can ensure that is by taking advantage of a single thread of execution. essentially the UI thread. So the order of events would be as follows. I type in a username, and if I were to click the connect button, the first thing that's going to happen is like a focus of or a lost focus event will be raised, right, by the presentation layer, by WPF. Upon that event being raised, that's the moment that we want this observable of string input to be pushed into the username observable, right? And we'll be doing that from the UI thread in the presentation layer. So lost focus event string arrives into the business layer because it's subscribed to this reactive input from the presentation layer. When the string arrives, it will do whatever processing it needs to do. The guarantee is that it will not introduce concurrency, right? That processing will happen on the UI thread. Therefore, invalid usernames is guaranteed to push a notification or not in response to the username being pushed in. And the business layer does not care which thread it's on. It's free threaded, right? This is one of the benefits of RX's implementation of reactive programming as well. It's free threaded in the sense that RX doesn't care which thread this notification arrives on. It will just do the work on that thread. And we can control in our query, if we want, and if needed, where the processing occurs. We could use schedulers to move it to another thread if we want, for example. But the contract for this observable is that we won't do that. The business layer is going to guarantee, this is one of the first contracts we're really discussing here, that the username and invalid usernames are sequential. So and synchronous, right? So it's blocking essentially. And then when the username is validated, nothing happens. So the call returns, the call from the UI thread that pushed the notification in returns, and then the user is now free to click the connect button. Now, in the case that it's invalid usernames will push a notification out before this one, the call to push the name into this observable, has even returned, right? Hence the synchronous part about it. It's blocking, right? So the UI thread will now get a notification that, because it's going to subscribe to this observable, which is output of the reactive program. So it's going to get a notification that the username was invalid. So this is like a synchronous feedback mechanism where I'm using two separate observables. But in order for that to work properly, in order to make sure that we're thread safe here and we can't slip in a invalid username to the server, right? Then at least, you know, this isn't about security, or malicious intent per se, but it's about because we're going to have to do validation on the server side as well for the same reason. But it's more about user expectation, right? We wouldn't want the user to accidentally submit an invalid username because they typed it in and clicked connect faster than the asynchronous mechanism, assuming we had some sort of concurrency introduced here, could validate it. So we want a synchronous mechanism or a blocking mechanism to do the validation, and we get that for free in this way. So what's interesting about this design is that we're not providing feedback about the username being successful. We're just providing the failure state. So in order to make this work properly, the success state is sort of encoded in the fact that this thing returned without this observable pushing a value. But that's okay because we don't care. The golden path is that it will be valid, and we could just assume it's valid unless we otherwise get a notification that it's invalid. So that works, but it only works as long as these two are synchronous. The clever trick of trying to disable the connect button actually won't help us, right? Because if we try to disable it, then when do we enable it? If we enable it at a point where now the next click, which may already be in queued, gets processed, then they'll click the connect button potentially before we know that the username is actually valid if concurrency was introduced here, right? So we can introduce concurrency here either way, in which case disabling the connect button until they enter valid information doesn't actually help us at all, right? It doesn't solve this problem. The solution is to make sure that these are synchronous. So a username gets pushed in, and then if it's invalid, invalid notification gets pushed out before returning to the caller that pushed in the notification to this username observable. So I think we have usernames, service URLs, and their validation completed for now. This is, I think, a good enough model. It solves our problems, and it's thread safe, and given the contract that that we've just defined, these two, actually both of them, right, are synchronous with their respective invalid observables. And when the user clicks the connect button, we will push a notification into iObservable of unit, which is a notification to the business layer to then attempt to use these values, which it already knows whether they're valid or not, right? So we should have some observables that implement these, which I think we do, but again, we don't want to look at the actual implementations. We're just thinking high level now, and the design contracts, right? So this is good enough. This models the username, service URL, and connect buttons. Then we have this concept of the server indicating that it requires authentication, and we have an observable output of that, which is just a unit because there's no data there. It's just the notification itself is good enough. So if the view subscribes to this observable, it will receive a notification that the server wants the user to authenticate, in which case it will toggle the visibility of the password and this submit button to be active. The cancel button will have already been enabled. As a matter of fact, we can even throttle it so that the cancel button doesn't appear right away, but only after a couple seconds or something. As a matter of fact, in most cases, you probably will never even see it because it will just be so fast to log in. But in the authentication scenario, we could force it to be visible if it's not already. So if the view gets a notification that authentication is required, it always will then make the submit button visible. If the cancel button has not been shown yet, then it will just show it immediately. And now you'll see submit and cancel. Obviously, this connect button will be invisible, so you won't see it. And then if the user clicks cancel, we need some input into the business layer, which we have here, cancellations. Again, no data there is necessary, just the notification that the user wants to cancel. And the user can cancel many times, right? That's why it's also, again, an iObservable. So then if the user cancels, then it will be a best effort to cancel. That's the contract here. So the view will just assume that the cancellation succeeded. It always succeeds. It's impossible for it to fail. That's the way the view will look at it. So it's going to be a robust API. And I think in the spec, if I remember correctly, I just defined any errors will just be logged and essentially swallowed, and we'll let the app continue in a state where it's a clean state, because any types that we had to create in order to represent the service, like a proxy or something, all those will be gone. We'll just clean up everything because you've canceled. So that will be safe. And the view then will be reset automatically to its original state. Now, instead of canceling, if we're in the authentication flow, then the user could click submit. If the user clicks submit, then we are going to push in a password. So we need an observable of string, right, which are the passwords. So when a password arrives to the business layer, then the business layer knows that its current state is that it's awaiting a password from the UI because it received an authentication request from the server. So then when the password arrives, it will complete the process by sending the password to the server. Now, the state at this point is the same regardless of whether or not authentication was required. So the business layer now is just, again, awaiting for the service to respond with a valid connection message, right? That the user is now successfully connected. So we'll definitely need some output there in order for the view to know when the connection is successful, and it could hide this view and transition away back to the main chat view, right? So I think that's the one piece of output that we didn't actually show here. And then the other one was connection failures, which we'll get to in a moment, but I had commented that out. Now is probably a good time to define the full contract for that, so we'll go ahead and do that. But we want to first think of the golden path, which is success. So we'll need some observable output that represents successful connection, right? So how about, oh, we have it. Sorry, connections. We already have it. I missed it. Yeah, that's it. So we covered everything, I think. That's pretty good. I don't think we missed any inputs. And this is a Boolean, which is actually interesting because this also indicates failure in a sense, right? Because if it's true, then it means we successfully connected. If it's false, oh no, that's right. Now I remember. And this actually makes sense. I think it's fairly intuitive. If this returns true, it means we're connected. So now we could transition to the chat window. If it turns false, it means we disconnected. It doesn't mean failure to connect. That's different, right? Because at some point you might be already connected and chatting, and you can pull your network cable out, and then you're gonna get disconnected. So this false would just be an indication that you're now disconnected. Now it could automatically reconnect, which then it would push another value with a true at some point in the future, and it could toggle true, false, true, false, true, false. So this observable will give us the current state of the connection, even though it might not require us to re-enter credentials or reconnect with specific information. If the user explicitly disconnects, and then to get back to this view where maybe they want to change their username or service URL or something, then they could do that as well. But that would be a different input, right? We'd want some way of saying we want to disconnect. So that actually we don't have represented here, but that's only because that's not a feature of this view. That's a feature of the chat window view. So we won't have to, we don't have to implement that one just yet. So the only other one we're missing then would be this connection failure scenario. So whether or not we authenticated, we could be in the state where the business layer is now awaiting for the server to respond with success message, or failure, or we could time out. Maybe we don't get a response in a timely manner. And that will encode that logic in the business layer. And then, at some point, though, assuming the connection wasn't successful, we want to send a failure message to the UI. Now, the failure message we're going to want to show in the UI. So we've already handled that, I think, right? We described the status bar as being the target for error messages like connection failure messages and so on. So that's also not part of this view, so we don't have to change that at all. Yeah, I think that's pretty good. So let's just implement this. And now connection failure reason, right now it's just an enum. Well, it's nothing, but I'm just going to go ahead and create an enum in a new file. And that could be whatever makes sense to us. Actually, instead of an enum, we could also just make it a string, right? Which is not so bad either. It depends. Do we want to display the actual error message from the server, or do we want a sort of, cleaned up, or rather, do we want to prevent the user from seeing some sort of implementation detail in the message and instead just show them some simple message that doesn't really provide much detail other than the connection failed? I guess it depends who your target audience is. Maybe if it's developers, you could just show them the full error and it wouldn't matter as much. But let's say for now we'll just stick with a nice clean enum, and the view could represent each enum value with whatever message it wants, and then we'll just log the server error. I think that was in the requirements actually. So what are the possible failure reasons? We could just come up with a few now that we know we'll probably have to consider. One is server did not respond in a timely manner, that kind of thing. So let's just call it timeout. Another failure reason could be, we could have none, which is the same as success, but you'll never see that, right? So we'll start out with none, so that's the default because it equals 0 in an enum. And then it could fail because, let's say, invalid username or service URL, right? So even though we're validating them, it's also possible that somehow somebody hacks around it and they get an invalid one to the server. It's still going to be able to have to respond with invalid, an invalid notification. So in this case, we could say like invalid username, invalid service URL, and we could treat those actually also as messages that get pushed into these observables, right? Why not? So that way the view can also react immediately when the connection failed with a notification that the username is invalid also. There might not be, we might in those kind of situations probably want a message that says why, but this is good enough for now. So invalid username, invalid service URL, invalid password. That's another one, right? And it could also just be server error, just some sort of general server error, right? I don't know that we necessarily need to distinguish that from timeout, for example. These could just be general server errors in some sense, but it's good enough for now. So that's our connection failure reasons. And you know what? I forgot to deal with input validation, right, on the UI. So we have the observables that represent invalid state being passed in, but I wanted to update the XAML so that it also can display it, right? So let me save that, move this to the previous tab group, and back into the world of XAML here. We want some way of highlighting that this is invalid, right? Now, there is the ability to have validation. It's built into XAML in a sort of very lightweight kind of way through bindings, if I remember correctly. It's been so long since I actually used that, frankly. So we could take advantage of that. That's one way of doing it. Again, it's not going to give us exactly what we want from a reactive perspective, so we're going to have to adapt if we decide to go that route. We could also just, create our own way of representing error messages here. We could, for example, this has a name on it, so it's available in code behind. We could inject it into the view model as well, so it has a reference to the text box, and then just set the style on it so that it has, or we could even bind to a style property or something for the view model so that it highlights the border with red. Or we could just, again, like I said, validation support in the binding, so we could do it that way too. But it's been so long since I've done it, I forgot actually how to do it. It's validation on exceptions. All right, so we could just throw an exception, but that's going to be too late, right? Because we want to do it on focus. So if I tab away, oh no, I guess that technically could work. We could just say validate on exceptions, and then just throw an exception. I forgot about this. Yeah, I remember this was actually kind of nice. And you could also, data errors requires you, and notify. Yeah, I remember this now. It requires you to actually implement an interface. I forgot what it was. Like I notify data error. Yeah, something like that. I don't remember. It's been so long actually since I implemented it. But I remember it being kind of nice. And I remember the data annotations library, I think it was, that's built in was also useful. But there was no implementation of it. And I remember writing my own a long time ago so that it worked in a very automatic way, but since then I haven't needed it. When you build the WPF app, I find it's almost easier to just build your own, style of displaying error messages for input validation yourself. It's not that difficult to do, so it seems to me like it's almost more difficult to try to relearn how to do this kind of thing every time you need it than it is to just build your own thing. But I don't know, validates on exceptions is probably the simplest approach for us now. Even though we don't want to raise exceptions unnecessarily, we're talking about, first of all, not the golden path, and second of all, one-off exceptions that, okay, they don't represent truly exceptional circumstances, but they are a quick way of getting validation failures visible in the UI, right? Now, if I remember correctly, though, you had to add a style to this. I remember the text box having a red border. I don't remember if that's because I used to add it myself or it was just implicit. The way I normally do it is not through this validation thing with the binding, but I literally just change the style to have a red border. Or if it's not the text box that I want to have a red border, you could do something else, like have a message appear under it or something like that. I don't think we need to go that dynamic with it. This isn't a web application, right? So a red box is probably good enough. And yeah, so let's go with this for now. I mean, if this doesn't work the way I'm describing it, that's fine. It's not that big a deal. This isn't meant to be a video on how to do WPF, and we'll just fix this later to work the way we want it to. But for now, I think we'll just go with this, and the idea is that in the username property, we'll just throw an exception when we get a, well, it wouldn't be in the property itself, but basically when we subscribe to this invalid username observable or invalid service URLs observable, when we get a notification in them, we're just going to throw an exception. And that's going to propagate all the way back up to where the username property was changed on the lose focus event right? Because that's by default the event that's going to, the text box will automatically raise, wait for it to be raised before it pushes the username into the property that is on the other side of this binding, okay? So this should be good enough, I think, but we'll find out in the future. Okay, so I don't think there's much more to do on this side. So, just out of curiosity, I'd like to see what we implemented already. Let's see how close this is. So we have users, which is the input usernames. We try to create the user, which is where we do our validation, right? We publish it because we're going to subscribe to this multiple times, as you can see from the highlighted users. And we want to share the subscription side effects. That is to say, the actual creation of the user or the validation. So then we have service URLs, which is the same thing, but for service URLs, try creating a URL. Then we have valid users, is a stream of users where the user is not null, because that's how we encoded validation. Null means that it's invalid. So valid service URLs is the same. Connects says that when the valid user arrives and the valid service URL arrives, then we subscribe to connect notifications. Yep, that looks good. So in other words, if the valid user changes or the valid service URL changes, then we resubscribe to connect, capturing this state and switch to it. The switch does the resubscribe, right? So each time we select, remember, we're not selecting a piece of data here that's like a scalar value or something. We're selecting an observable. So it's an observable of observables, right? Switch then will switch to each of the inner observables and unsubscribe from the previous one, subscribe to the latest one, and so on, and just keep making sure that we're always subscribed to the latest observable, switching to the latest observable. That gets projected from this select operation. So when the valid user or valid service URL changes, we switch to a new observable awaiting the connect button to be pressed. And this all happens on the same thread because there's no concurrency being introduced here whatsoever. So this is going to be set up on the UI thread if we're pushing in notifications on the UI thread, which we know we will be. So this will all run on the UI thread, including the switch will all happen on the UI thread. Everything's going to be synchronous, which is nice. RX doesn't care because RX is free threaded. So if we want to introduce concurrency, we can, but we don't in this case. That would introduce race conditions that we don't want to have. So just setting this all up on the UI thread is perfectly reasonable. So what do we do with connects? Nothing yet. Well, we do connect to the users and service URLs later because they're published, so that's important. And then we generate our invalid usernames and invalid service URLs output by looking for users that are null and service URLs that are null, and just projecting them into unit notifications, voids, if you will, right? Okay, so what else can we do here? The connection view is done for the most part, so maybe we can move on to the chat view right now. I know I probably would run out of time, but let's start it. Yeah, I'm going to start it. So let's go to the chat view. The chat view, if I collapse the definitions here, has a few things in it, right? We have this flow document scroll viewer thing, which is where we're going to have all our chat messages listed. And there's a scroll bar that comes along with that. Then on the bottom we have a text box for sending, entering messages. This button was for styling of messages, right? It's not letting me press it. There we go. Which is, yeah, this toggle button here for showing the styles, which is this little drop down thing here. Huh. It's not actually dropping them down. Oh, because it's toggled off, right. I could force it to show it by setting this to be is checked equals true, but I don't have to do that right now. Anyway, we know that's just styles and fonts and whatever your choices are for styling the message. And then we have a send button, which is right here. and this sends the message. Pretty simple interface. All right, so I think we can do something similar here. I'll put that over here and then dock this to the right. Get rid of the connection. Okay, so back to the beginning again. What are the contracts now that we need? So let's go to the input. What input do we have to meet our requirements from the view's perspective? From the perspective of the view looking at the business layer, or the presentation layer looking at the business layer, we have an iObservable of string, which represents the messages going in. Although I think now is a good time to define a type called message, because that's going to have additional information like formatting details and so on, right? So this is sort of another, it's an alternative way of representing the input to the business layer when compared to, say, the usernames and service URLs. So this could have been like some connection type. I think I brought this up a couple times already. So we could have had a connection class or something like that, which is really just a tuple in that case, right? With just the username and the service URL. And it's just raw input. It might not even be validated information. But I decided because we want validation and I want it to be a little bit more specific relative to the actual written specification, I separated them out. But you could see doing it this way too, where you just have a discrete type that contains everything, and then you just have a single observable that pushes a notification with that data. And there's other reasons to use one over the other, but it depends on various factors that we don't really have to get into now. You'll know which is the best for you based on the requirements when you look at things from the perspective of the presentation layer looking at the business layer, right? So in this case, looking at it in this direction, we see that having a message type is good enough, right? Because when we click send, we know that that's going to be something that pushes in a message, which is the thing you typed plus all its formatting information, to the business layer. So one observable containing a data type called message is good enough, right? Anyway, I think I've convinced myself it's good enough. So now we're going to go to the chat. Oh, I'm in the business layer already, right? So I could just generate a new file here, a new class and a new file called message. This will be a sealed class that has just a few properties on it. Text. We'll make it an immutable type because, again, if we're using it as data, a data type for an observable, we should always default to immutability. Mutability will cause trouble potentially for you down the road. If you're immutable, then no trouble, and everything's thread safe. So always start there. And you know, again, mutability is something we may or may not introduce into the app if we ever need it, but probably not. And it's something that's tricky, and you don't want to just throw it in. So we're gonna stick with immutability, obviously, if we can. In this case, we definitely can. So we're gonna have the message, and then you know what? I don't remember what all of the requirements are. Let's just pop open the spec and just see. Or actually, was it the feature list? Okay, so the feature list has I think I described it. Client features. Here it is. Font, size, and color. Yep. And it only affects subsequent messages. So we also wanted to keep that information, so it has to be stateful. But we're in the view layer. This is going to be a view model backing this thing. The view model will just keep track of that information in the state. So that doesn't necessarily have to be a reactive problem for us to solve, right? Okay, so font size, color. I think that's good enough. And then just the text of the message, right? Yeah, I guess that's good enough. Now, the message would also potentially have other information like the user that's sending it, but I don't think that makes sense for the UI to be responsible for putting that information in. I mean, what if it gets it wrong, right? The business layer is going to be responsible for that so that it could send that information to the server properly. Although, actually, I guess technically that's implied. The connection, so each socket connection to the server will have, because we're going to create persistent socket connections probably. That's my plan here. So like WebSocket or something we'll probably end up using, and it will just be a persistent connection. So each connection will correspond to a single client. Therefore, once you've authenticated, we know which socket corresponds to you. So any messages coming in, we know they're your messages. So we don't have to add additional information or encode any other information into the message, which could have, of course, also be spoofed if we were going to rely on it that way. So yeah, I think this is probably good enough. So we don't need to identify the user here. Definitely not in the view layer anyway, but maybe in the business layer, probably not, as for the reasons I just described. So then we also need font. So perhaps font will just be a string, font family. Size, I think we could do it as a double because that's what WPF uses, and it doesn't have to be super precise, so we don't need it to be decimal. Although technically, I don't know that we need it to be double either. I think float would probably be good, but I'm pretty sure WPF uses double for font sizes. So we'll just stick with that for now. You know what, let me just double check that. I don't think there's like a font size type, right? Oh, there is. Oh no, font size is double. Yeah, it's a property on the current control. So font size is double, yeah. And then we have color, right? So how do we want to represent color? Now this type is not a data transfer object, so we don't have to worry about serializability at all. As a matter of fact, I would argue that we shouldn't. We should just represent it in a way that's makes it easier for us to consume the data in case we have to, do something with business logic. Not that necessarily you're gonna have any business rules based on coloring, but I think it's nice to represent the state in a way that makes sense. The only problem is we're in a business layer and we don't have access to the types that are defined in the presentation layer, nor would we want to, because we want to be able to write a business layer that could work on any platform, including web, for example. So how we need a representation for color that's really platform agnostic. So I think the best way to do that would be to have a, well, I guess we have two choices, right? We could do a string, but then it could be invalid. You could have invalid color information, which I don't like. I think I'd want something that's at least guaranteed to be valid, in which case we could just define our own color struct in the business layer, which would probably be good enough. But then we're going to have to adapt that struct to the color structure that's defined by WPF and any other presentation layer we implement. We depend on. Which is fine, because even if we did it as a string, we still need some way of converting between string and that type. So we're going to need a converter regardless. It has to happen. The benefit of string is that you usually have built-in converters for color types to string and back on any given presentation layer. Whereas if we define our own color struct, it'll be up to us for each presentation layer to perform the conversion. So really we're just weighing two things here. I think it boils down to, do we want to allow there to be the potential for invalid color data or not? And my intuition is that I prefer a more strongly typed structure. So I don't think string is the right approach here. I think we should have some color information encoded. Now, I don't have to make an struct either. I could just put those fields directly on this class, but I'm just going to go ahead and create a new type that we'll use for color. Now, we could just call it color, or we could call it font color. It would also disambiguate it name-wise from the struct also called color in the Windows library. But perhaps that's not good enough, because we might want to reuse it for other things. Maybe there's other reasons to have color or styling with a color property or something, and then it's not necessarily related to a font. And we're not really defining color that has anything to do with fonts specifically, right? It could be a background color or something. I mean, based on the data we're going to be containing in this structure, it could also represent a background color. The semantics are not defined. So maybe we could just call it color, and then the fact that there's some ambiguity, we'll just use namespaces to disambiguate. Perhaps not the best choice, but good enough for now. We could call it chat color. But then that's the whole point of having a namespace. We could just do chat.color, same thing, right? I'm just going to call it color. That's what it is. So in the business layer, we deal with colors. We have our own struct for color. although I just want to double check actually while I'm in here that there is no actual color type defined anywhere. Oh, there's console color. Yeah, but I don't like console. Console color is not really what we want. Okay, so console color I think is has predefined colors. That's not what we want. We want any open-ended RGB or a RGB value, right? Okay, so let's just go with this. I think this is good enough. So we're gonna have color. What is going to be the default? The default color will be, I guess it's going to be all zeros. So it's not even black, right? It's really transparent in a sense. I don't know. Well, yeah, that's good enough. So transparent will be the default color. And then we'll have one constructor which takes in, I guess it could just be, well, we could just use a byte, right? Yeah, so let's just do that. So it'll be a byte, which will be the alpha component, red, green, blue. The reason why I was RGB, right? The reason why I was pausing there about byte was because I was thinking we could also just take an int, because an int is 32-bit, which is the same as 4 bytes, right? So it's the same as 4 bytes. We could just represent it as an int, but I think I'd rather just that's going to be encoded too much, right? I don't like that. There's no reason to do that. This is cleaner. So yeah, so this is a signed byte 0 through 255, and that's going to be the code encoding for our color value. Yeah, I'm happy with this. This is good enough. Pretty standard color structure, I guess you could say. So we're going to have alpha, red, green, and blue. By default, if you construct a color instance without calling this overload of the constructor, the implicit constructor for a struct is parameterless. If you invoke that one to create a color instance, then these will all be assigned to their default values. For byte, it's 0, so they'll all be zeros, which is why I call this transparent, because alpha will be 0. 255 will be opaque, 0 will be totally transparent. So it doesn't really matter what these values are, because if it's totally transparent, these values are irrelevant. So I just called it transparent. Okay, so then alpha equals alpha. Red is red. Huh. Green is green, and blue is blue. That's weird. It's getting the casing wrong. Okay, so there's our color struct. And, you know, I don't want to waste too much time, but like all good structure implementations, it must have a equatable. So I'm just going to go ahead and do this because I think it really should have it. So how do we know the colors are equal? Well, if the alpha is equal to the other alpha, and red is equal to the other's red. It's not formatting it nicely. Green and blue, green and blue. Then they're equal. We also have another equal untyped overload, and we're going to say this is equal if object is a color, and oh, we're in VS 2017. We're using C#7, so I can just say this, I believe, right? Object. No, that wouldn't work. Yeah, because it thinks it's a bool. Of course, duh. No, it's like this. It's object is color. No, it's object as color C and equals, oops, C. Ah, but this isn't going to work because I don't think you could do this with a struct reference type or a nullable type. Yeah, so I guess I'm just trying to use that. I haven't actually used this feature, so I was hoping to just use it for now. I mean, for the first time. But yeah, I guess it's not going to. Excuse me, it's not going to work because it's a struct. But so what? So this is the normal way of writing this anyway. And let me just make sure this calls into this one. Yes. And then we also want to implement get a hash code, which is a piece of cake that is going to be other alpha. Oops, not other alpha. Alpha. And I'll just do the what the hell is this operator called? Exclusive OR, I think, right? Yeah, exclusive OR. So, or, well, it's exclusive. Oh, no, it's not exclusive. Yeah, exclusive OR, right? Even for bytes, that's what it's called. But, yeah, anyway, that will generate a good enough hash code for us. We're probably not going to be using this thing as a key in a dictionary or something anyway, but I'm just trying to be complete here in my structure implementation. And then we're going to have public static boolean operator equals color, let's say first and color second is first equals second. And then likewise, not equals is not first equals second. And these are all pointing to this one. All right, that looks good. And then last but not least, toString for diagnostic purposes. We'll just render it as, oh, we could do hexadecimal, right? Is it bit converter? Converts each of the specified array to its equivalent hexadecimal string representation. Yeah, that's pretty nice. We have to allocate an array for it, but so be it. So it's going to be ARGB. I wonder if I should just call them ARGB instead of alpha, red, green, and blue. Is that too verbose? Nah, it's good enough. I'm happy with it. Okay. So there's a standard color structure implementation. And now we can say color, font color. So I probably wasted some time building that, but I don't care. It was fun. So we have text, font family, size. You know, font is sort of redundant here. Yeah, we could just say color. I guess here it's not redundant. The family of what? It's the font family. Maybe we could just say font. Nah, that implies, you know, if you're used to web programming, that you pass in more information than just the font name or font family name. So we'll just stick with this, font family. Okay, I think it's pretty good. And obviously the constructor, string font family, size, color, color. All right, I'll just correct the cases after. Oh, I am not good at typing today. Yeah, there we go. Okay, that looks pretty good. And we don't have to do anything for this, but I do like putting toString implementations. Obviously, for diagnostic purposes, it's pretty useful, right? We could say, well, let's just go with just the text for now. Okay. So there's our message class. That's nice. So now we have an observable messages coming from the GUI here. Oops, these are reversed now. Like that. Yeah, there we go. So you click the send button, and the view model will have this information in it, all the state necessary in order to construct a message type, and then we'll just push the message in. Pretty good. So do we need any other input to the business layer? Do we care about the function of this button or the text box? I guess not, because all that really just gets wrapped up into a message type. Okay, so that's good. And then we have to worry about output, though, right? So the output is going to be messages coming in to the presentation layer that it could then render here. But this is interesting now. These messages have to include additional information like the username and maybe even a date time stamp, right? And other stuff. We could look at the feature list. So now we have to wonder whether or not we want that to be on this message class or another message class. What we could do is just it's immutable anyway. Keep it on this class, but have two constructors, right? So one constructor doesn't require that information because it's a message being generated from a chat client, and one does require that information because it's being generated by a chat, by the chat server. So that's one option. That's probably the option I'll go with. But let's represent the observable first. So that's going to be an iObservable here of output. Oh, you know what? I forgot to actually put public on all these. Yeah, that would have been smart, huh? There we go. Yeah, sorry about that if that was confusing. Of course, it's output. It needs to be public. But anyway, so now we have this message, and it's obviously not no setter there. It's a getter. We'll construct it in the constructor, but we're not going to do that now. And this observable message we can subscribe to in the view. So do we want to reuse the message type? Yeah, I guess so, right? Otherwise, we have to define a separate type. I'm not sure it really is all that necessary or makes all that much sense to have a completely separate data type, which has, I mean, a separate type that derives from this. Polymorphism here isn't really making our lives any easier. It's just, we really just have two scenarios to construct the type, so why not just have two constructors? I think that's the simplest way to represent this requirement. We have two cases in which we need to construct the message, and in one case is more data than the other. So we'll just have two constructors on the type. Yeah, I don't think it gets any simpler than that. So what else do we need? We know we'll need like username. Excuse me. Oh, actually, instead of username, we will have user, because we have a discrete type for user, which could have additional information in it. So why not encode that? You know, that seems reasonable to me. And actually, this constructor could just call into the other one with the other shared state. And then we'll have additional properties for this, like user equals user. And what else do we need? I don't remember. Let's go to the features. I keep going to the wrong thing. Okay. So where do we go? Client features, part 1. Client features, part 2. Here it is. Option to display date and or time with each incoming message. All right, so we'll have like a date and time stamp. Chat history, completely separate requirement. Font size, color, we already have. Sound, completely orthogonal to this problem. Optionally have a sound played, same thing. Filter messages by username or search criteria. Usernames encoded in the user type. Status is interesting. Maybe the user's status at the time we received their message. Do we want to have that information? Maybe it's useful for historical purposes. So in other words, instead of separately saving the status of the user in a separate file or stream or something, it could just be encoded in the message history itself with each message. What was their status when they sent a message? Well, then we lose information about when the status changes and they're not actually sending messages. So yeah, that's not really all that useful. So yeah, let's skip this. We don't need to have the status in the message. Yeah, so I think that's good enough. Just daytime. Oops. And they could be anywhere in the world, so we'll use datetime offset, so it includes time zone information, right? And we'll just call it, how about when? I know most people write date time or date time or date or time or what, but to me that just doesn't make sense because it's the same as the type and it's always the same. I don't know, I kind of like just writing when instead or something like that. Or like, you know, message received at or received, you know, we could even say like received. Yeah, there we go. Or sent. Well, see, now this is better because now we're talking semantics, right? What does this daytime offset actually represent? Is it the exact time that the message was sent or the exact time that it was received? They could be very different, right? Especially if we eventually implement reliable messaging and you're forced, you're guaranteed rather to receive every message. Well, there could be a big delay before you receive it. I guess in that case, sent is really the useful information. Received is not that useful because it's always now, right? You know when you received it. It's at the time that it pops onto your screen. Unless you walk away and come back later, then you might want to know when you received it as well. Potentially, you could see maybe both pieces of information being useful. I think we'll go with what makes the most sense, is to me anyway, is sent. So knowing when the system thinks that it was originally sent, that's the important piece of information. That's what we'll display to the user if they want to see that information. So I'm okay with that. Let's go with it. Sent. Okay, there's our message class, and it serves as both the data type for both input and output of the business layer to the presentation layer, but also input and output to the service layer, right? Output from the business layer is also input to the service layer and the presentation layer, right? So the service layer could just subscribe to this observable messages in order to get messages coming from the user. And this would make sense if we want to, for example, have the user's message that they enter appear immediately in the chat window. So the message that we send goes into here. It gets enriched into basically a new message gets constructed from it, but also the current user's information is added into it, the current datetime offsets timestamps added into it, and then it's received by the server or the server URL, the service layer, and also the presentation layer, and the presentation layer just drops it in here. However, that might not be the best approach because that means that we're seeing the message appear here even if the server hasn't necessarily received it. Maybe that's not the way we want to do it. Maybe we want the message not to show up here until we get confirmation that it actually went to the server. In other words, the server is going to multicast to all subscribed clients all of the messages it receives. We could also have it reflect back the message as part of that multicast operation to the sender of the message. So the sender just becomes like any other observer of the message, but it's its own message. And in that case, we would treat on the view layer, we would treat it the same way as any other message, even though it's coming from yourself. And the date time offset will be the either we could decide when we implement this whether or not the timestamp happens on the client side, on the chat side, before we send to the server, or whether the server is responsible for stamping it. But we'll decide that later. But for now, I think it's important that we decide whether or not we want to have our message appear right away, or we want to wait for the server to confirm essentially that it was sent by multicasting it out back to us. Will be included in the multicast list, in other words, the observer list. I think I'm going to go with the latter. I'm going to make it where we actually don't send this message in to here. So in other words, this observable is input to the presentation layer, but it's not input to the service layer, right? Because the service layer won't receive the user's message in here. It would have to therefore subscribe to reactive input, but this isn't good enough because the business layer is going to have to enrich it and, you know, maybe do other businessy things to the message before it even hands it to the service layer to dispatch it to the server. So we will need a separate observable for that. Now, I'll probably completely forget this. Normally, you know, you might document this kind of idea or put it as a to-do. I'm not going to do that because it doesn't really matter. I'll probably forget this this conclusion, but I think this makes the most sense to me. And I don't know. Let's see if I remember it in a future video when we work on the service layer. Let's see if I end up going the other route and making it so I just subscribe to this. I could see myself just being lazy and subscribing directly to this instead, and then just routing messages to that, like I said originally. But I don't think that's the right approach. So anyway, I've stated my case for that. We'll see what happens in the future. Okay, are there any other features in the chat window that we need to worry about? I think now is a good time to go back to the spec and just I'll just close these other windows and let's just see where we're at here at the moment. So we haven't done anything with cross-cutting concerns yet, which is obviously something we're going to have to do. These are all important things. Diagnostic tools. Yeah, definitely something we're going to want to do, but we haven't done anything with those yet. That's probably not going to be for a while also, at least a few more videos. So specification part 1, client design. Startup, we have not done anything with that yet either. I think most of this is not reactive stuff, which is why I'm probably going to push that off for a while just because it doesn't really matter. It will have to happen to build a quality program, but it's not reactive, so I don't want to spend too much time on it. Certainly don't want to worry about it up front. Part of this, though, is going to be, composing our object graph for, the dependencies that the business layer will require. This is a fairly simple app. I don't know that there's really going to be many anyway, so it's probably not that big a deal. But I don't like inversion of control. I'm not going to be doing anything with that. I'm just going to build use object composition, constructors, and any dependencies. I'll just build an object graph, and then that will be the program. So maybe like we have reactive program, I'll just have object-oriented program, just to be very explicit about it, and then compose the graph that we need. Like I said, it's going to be pretty simple in this app anyway, so certainly no need to go all dynamic with inversion of control or anything. And then that will probably be the only really important part that's related to reactive programming, dealing with startup, because composing the graph is going to also require us to think about how to and when to construct the reactive input type, an instance of that. Oh, I forgot I don't have it as a separate file yet, but we'll have to create an instance of that and glue that to the view model. So there's going to be dependencies, right? So we'll have to figure out how to essentially go from this object graph to this reactive graph, if you will, which it's still an object graph, but the reactive query or graph is going to be is defined in the constructor here. So this is like adapting this object-oriented world. This reactive input thing is object-oriented, right? It's a class with a bunch of observables. Somehow these will have to be composed with their dependencies in some object graph, and then passed into the reactive world through this constructor, right? So we'll get to that again sometime in the future. Connecting to the server. So we have already gone through most of this, right? We skipped the animation concept, but whatever, doesn't matter. Try connecting. Yeah, I mean, I think we covered everything here, actually, including the authentication flow. I mean, this is high level, right? We're just talking about, although we did actually implement it in the business layer, I was really most concerned with just the interface, the contracts, the input and output observables, and I think we've covered them, so they're good enough. They're meeting our requirements for the initial presentation layer that we've built so far, the GUI that we built. So good enough for now. Okay, then, right, so this part done. Then when the disconnect button is pressed, disable it. Disconnect. Completely forgot about that. Yes. So, is that part of the main window? I forgot if it did. Maybe I did add that in. No, I didn't. So the main window starts with just this connection view, and at some point will obviously get swapped out with the chat view when we get connected. But I wanted the ability to be able to disconnect or log off, right? So we'll have to have some place to put that, some control. The question is, do we put that in the chat view? I would argue no, because, cohesion and all. It seems weird to put disconnection function in a chat view control. So we'll probably put that somewhere in the main window. Actually, we might even have like a file menu at some point for dropping down settings and file exit and that kind of stuff. So maybe just putting it there would be good enough. We could also have like a toolbar with a button, but it's probably going to be the only one, so I don't know if the only button makes sense. And I don't like putting functions in a status bar, like buttons in a status bar. So yeah, we'll probably end up just going with like a simple drop-down file menu or something. Okay, so for that reason, I'm just not going to deal with that now then, because it's not in the chat view, and I don't want to start working on the main window now. So disconnect we still have to do, fine. And receiving messages. So when a message is received, there's some business logic here. We'll have to implement that. Probably won't do that until we cover the designing of the contracts between the service layer and the business layer first. And then we'll go ahead and implement these rules based on those inputs and outputs. Sending messages likewise. But we do have message observables for the presentation layer, so that, at least that's covered. And server design we didn't even get to yet. Disconnecting, removing client, this is server-side stuff, right? And multicasting, as we actually discussed. there's some rules around that, and that will also be server-side stuff. So I think for part 1, we are in pretty good shape regarding connecting, regarding connecting to the server and sending and receiving messages from the presentation layer's perspective, and even the business layer's perspective from, referring to the contracts involved in communicating with the presentation layer. So I think the next thing that would be also fun to do would be to start dealing with the contracts between the business layer and the service layer. So let's plan for the next video to start thinking about the service layer and the contracts between the business layer and the service layer. And then hopefully we'll get to a point where once we've got all the designing done, we can start building from the inside out, and maybe even start by jumping into the server design and implementing this stuff, because it's actually fairly simple for what we want to do, right? There's no requirements about reliable messaging or anything like that, so we'll create a very simple service to handle our needs, so that we can go up to the business layer and start implementing all of the fun business rules as reactive queries, or composing reactive queries together from all the inputs and outputs that we've defined. So that's going to be fun, I think. And now, what about a challenge? Leaving you with a challenge. I guess if you're really up for it, start, coming up with your own idea about what kind of inputs you would want into the business layer coming from the server or the service layer, right? That might be interesting. So you can imagine splitting this up to, presentation layer. I mean, we could even have separate types for them. But this is also good. Now, remember, like I said, we're going to have one object graph that composes all the inputs together anyway based on the dependencies. So we could also just have one type. I'm not sure it makes all that much of a difference. So this will be our data layer. Or, well, just call it service layer. I'll stick with that for now. I always think of the service layer as being in the data layer. It's like a sub-layer or something. But anyway. So, yeah, if you're up for it, maybe starting to implement these observables and coming up with these based on the specification, that could be interesting. And then, likewise, the outputs could be interesting as well. So these would be also presentation layer outputs. I'm wondering now if I should just move them into a separate reactive output class as well, just for consistency. I mean, the number of these are going to grow anyway. I'll leave it like this for now. I don't want to introduce something at the end of the video that's sort of disruptive. So I'll leave this for now. But at some point, yeah, it's likely we're going to have classes to encapsulate all these things anyway. So yeah, if you're up for it, this is the challenge I will leave you with, but nothing real specific. So it's more just practice if you want to start coming up with your own ideas about how you would do it. I might make different decisions than you when I implement it. It doesn't necessarily mean that you were wrong about it. As a matter of fact, it could mean that I was wrong, that I didn't do it in a way that's going to work out as well. But that remains to be seen. And the point is that you're probably not going to get it right in the first try. I rarely do. It requires multiple iterations. So it's more about the exercise and just thinking about, practicing thinking about these kinds of problems in terms of input and output and streams and observables, in other words. So there you go. And thanks for watching this video. And I hope you join me for the next one.